1979 of the textbook. We're going to start on number 13, which says find the value of 5 squared times 7 squared. To square something means to multiply it by itself. So 5 squared is 5 times 5, or 25, and 7 squared is 7 times 7, or 49. So we need to find 49 times 25. So we're doing multiplication here. We're going to first multiply by the 5. 9 times 5 is 45. 4 times 5 is 20, plus 4 is 24. Now we're going to multiply by the 20. So if we're multiplying by 20, it's like multiplying by 2 and then by 10. So we add a 0 for the 10 part, and now we multiply by 2. 2 times 9 is 18. 4 times 2 is 8, plus 1 is 9. We add, and we get 1,225. Now we need to find the prime factorization of 72. To make a prime factorization, we break it down into only prime factors. So we can start with any two factors. I'm going to start with 8 and 9. And then I break down each into smaller and smaller factors until they are all prime. 8 is 2 times 4. 4 is 2 times 2. 9 is 3 times 3. Now I have all prime. And I combine them. I do my smallest factors first. So I do 2 times 2 times 2, and then 3 times 3. But then I combine like factors using exponents. 2 times 2 times 2 is 2 to the third, and 3 times 3 is 3 squared. So my answer is 2 to the third times 3 squared. For number 15, we just need to simplify these fractions. 6/8, we can simplify that because there is a common factor to both the numerator and denominator. They're both divisible by 2. So if I do 6 divided by 2, I get 3, and 8 divided by 2, I get 4. And 9/15, they have a common factor of 3. So I divide 9 by 3, I get 3. 15 by 3, I get 5, 3/5. Number 16 says to express each of the following as an improper fraction. So we start with a mixed number, and we want to make it improper. So we did learn a shortcut to this. We learned that we can take this denominator times the whole number. 8 times 5 is 40, and then add the numerator. And we get 43/8. And this makes sense because each of these whole numbers is 8/8. So 5 times 8/8 would be 48, plus the 3/8 would be 43/8. So here on the next one, we can use our little shortcut. 11 times 3 is 33, plus 7 would be 40/11. Number 17, we want to express each of the following as a whole number or a mixed number in simplest form. So now we're going the opposite direction. Now we are starting with an improper fraction, and we're going to extract as many whole numbers as we can. So if we have 26, we ask ourselves, how many 6's go into 20? How many whole 6's? And that would be 3. 3 6's would bring us to 18. We would have 2 6's left. So we would have 3 and 2 6, but that can be simplified to 3 and 1/3. 16/4, we ask ourselves how many 4's, how many complete 4's go into 16, and the answer is 4 even. So this one is a whole number, 4. 18, name 2 equivalent fractions to each of these fractions. So this one, you could have a variety of answers. You could have infinite number of answers, but I'll just give 2 for each, but you might have different ones. 3/4, I could say that's equivalent to 6/8 just by multiplying numerator and denominator by 2. I could say it's 30/40, and there I multiplied by 10. 3 times 10 and 4 times 10. I could say, I could multiply by 3, and I could say it's 9/12. 9 times 3, or 3 times 3, and 4 times 3. So infinite number of equivalent fractions there. You can multiply, as long as you multiply the numerator and denominator by the same number, you're going to have an equivalent fraction. For this one, 2/6, I could simplify that and say it's 1/3. Or I could multiply by 2 numerator and denominator. 2 times 2 is 4, 6 times 2 is 12. I could do that. I could multiply by 10 and say 20/60ths. So again, infinite number of possibilities there. Now we're on number 19. And on 19, we want to divide and express each answer as a fraction in simplest form. So 8 divided by 12, remember division is like a fraction. So 8 divided by 12 is 8/12. And then we just simplify it. I see that 4 is a factor of both. So 8 divided by 4 is 2, and 12 divided by 4 is 3. So 2/3. 15 divided by 54 is 15/54. And I want to find a common factor. I know that both divisible by 3 because the sum of the sum of the digits of each is divisible by 3. 1 plus 5 is 6, that's divisible by 3. 5 plus 4 is 9, that's divisible by 3. So I know that each of the numerator and the denominator are both divisible by 3. 15 divided by 3 is 5. 54 divided by 3, I don't know that off the top of my head. So I'm going to go off to the side and I find that it's 18. So it's 5/18. On number 20, they want us to say which is greater. So I have 3/2 or 5/4. 3/2 is actually more than 1 because it's 1 1/2. And this one actually is more than 1 as well. 5/4 is 1 1/4. So what's more, 1 1/2 or 1 1/4? Hopefully you know that a half is more than a fourth, so that is greater. The 3/2 is greater. On the next one we have which is greater, 2 1/2 or 2 1/7. So the 2 part is the same on both, so we want to look at the fraction, which is more, a half or a seventh. And again, hopefully you know that a half is more than a seventh. 3 8/9 or 4. Well, 3 8/9 is not quite 4. It's less than 4. So 4 is going to be greater there. 23, we are just adding or subtracting. So our first one, we have 5/6 plus 3/4. To add fractions, we need to have like denominators. So we look at our two denominators and we ask ourselves, what is a common multiple to both of them? And it's going to be easiest to use the lowest common multiple, which in this case is 12. So I'm going to change them to 12ths. So 5/6, I ask myself 6 times what is 12? 6 times 2 is 12. So I do the same to the numerator. 5 times 2 is 10. 3/4, I'm going to convert to 12ths. 4 times 3 is 12. So I need to do 3 times 3 and get 9. I get 10/12 plus 9/12, or 19/12, which is 1 7/12. Part B, I have 2 1/2 plus 5 4/5. So I need to convert my fractional parts to have like denominators. So 2 and 5 are my denominators. The least common multiple of those are 10. So that 1/2 I'm going to change to 5/10, and the 4/5 is going to become 8/10. So now I can add my whole numbers. 2 plus 5 is 7, and now I add my fractional parts. 5/10 plus 8/10 is 13/10. But I have a whole number in 13/10 because that's really 1 3/10. So I combine the 1 with the 7 and I get 8 3/10 left over. The last one here is subtraction. 4 3/4 minus 2/3. I am going to write this one vertically. sometimes that makes it easier for me. I need to make like denominators, so I have 4 and 3. I know that 12 is the lowest common multiple of those. So the 3/4 becomes 9/12 because I'm multiplying numerator and denominator by 3. And the 2/3 becomes 8/12. I'm multiplying numerator and denominator by 4. So now I can do the 9/12 minus the 8/12 is 1/12, and then I have 4, and then I have no whole number here, so that stays 4. So 4 and 1/12 on that one. Number 24 has us multiplying a whole number times a fraction. So we learned this week a little shortcut for these, because originally we learned we could just do 7 times 4 over the denominator 20, and we would get 28/20, which we could simplify. We could divide by 2. Actually, we could divide by 4 and get 7/5, or 1 2/5. But we learned this week that we could actually simplify before we multiply. So we see in our numerator and denominator, they're both divisible by 4. So we can simplify here. We can do 4 divided by 4 is 1. 20 divided by 4 is 5. So we get 7 times 1, or 7 over 5. So I get 7/5, which I simplify to 1 2/5. And I skipped kind of all of that by simplifying before I multiply. Okay, so for this next one, 24 times 5/8. So that is 24 times 5 over 8. Again, I'm going to simplify before I multiply those numbers out. It'll make it easier. I'll be working with smaller numbers. So I know 8 goes into 24. So if I divide both by 8, I get 8 divided by 8 is 1. 24 divided by 8 is 3. So I end up with 3 times 5, or 15. And that's my answer. 15 over 1, which I know is 15. 15 divided by 1 is 15. Okay, the next one, 35 times 2/5. So again, that's 35 times 2 over 5. And we can simplify before we multiply again. So 5 goes into 35 7 times. So I end up with 7 times 2, or 14 over 1, which is just 14. On number 25, we are converting to different units. So here we're starting with 3/5 meters. We want to know how many centimeters. We know there are 100 centimeters in a meter. So 3/5 meters is just 3/5 of, or times, 100 centimeters. So now we're just doing our fraction times whole number multiplication. 3 times 100 over 5. I can simplify before I multiply. 5 goes into 120 times, and I get 3 times 20, or 60 centimeters. The next one, I'm starting with kilograms, and I want to make it kilograms and grams. So I have 1 7/10 kilograms. So the 1 is 1 kilogram, so we'll put that with the kilograms. So we just need to convert this fractional part here, 7/10. We want to say how many grams is that. So we need to know how many grams in a kilogram. Kilo means 1,000. So 1 kilogram equals 1,000 grams. So to convert 7/10 kilograms to grams, we say 7/10 times, or of, 1,000 grams. 7/10 of a kilogram is 7/10 of 1,000 grams. So now we can simplify before we multiply. We can divide by 10, a number in the numerator and denominator, and we get 7 times 100, or 700. So 7/10 kilograms is 700 grams. Another way to think about that is you could say, what is 1/10 of a kilogram? If a kilogram is 1,000 grams, 1/10 of 1,000 is 100. So if 1/10 of a kilogram is 100 grams, 7/10 is going to be 7 times 100, or 700. 2 3/4 pounds, we want to convert to pounds and ounces. We need to know here that 1 pound is 16 ounces. So the pounds can stay, the whole number here, 2, can stay with the pounds, 2 pounds. So we just need to convert the 3/4 pounds to ounces. So 3/4 of a pound is 3/4 of 16 ounces. So 3/4 times 16 ounces. And here again, I can simplify before I multiply. 4 goes into 16 4 times. I end up with 3 times 4, or 12 ounces. And again, I could have done that one in my head as well, because I could have said, what is 1/4 of a pound in ounces? Well, 1/4 of 16 is 4. So now 3/4 would be the 3 times the 4, or 12 ounces. 2 more problems. We have some story problems. Number 30. It says, Bonita bought 2 1/5 kilograms of potatoes and 1 1/2 kilograms of carrots. How much more potatoes than carrots did she buy? So we want to know the difference. We're subtracting. So we're taking the 2 1/5 kilograms of potatoes, and we're subtracting the 1 1/2 kilograms of carrots. So to subtract, we need to have like denominators. So we're gonna look at this 5 and this 2, and we're gonna think, what's the least common multiple, which would be 10. So we're gonna change the 2/5 to the 1/5 to 2/10, and the 1/2 to 5/10. Now we have a little problem, because we cannot subtract 5/10 from 2/10 and get a positive number. So we are going to make this fraction bigger, and the way we do that is by taking a whole number out of this 2. So we take 1 away from this 2 and we make it 1, and we add that back to the fractional part as 10/10, which is equivalent to 1. So we add the 10/10 to the 2/10 and we get 12/10. So we end up with 1 minus 1, which is 0, and then 12/10 minus 5/10, which is 7/10. And what are we doing? Kilograms. So the potatoes weigh 7/10 kilograms more than the carrots. And finally, number 31. There are 42 classes in Miss Brown's class. 3/7 of them wear glasses. How many students wear glasses? So I'm going to draw a bar model for this one. Let's see here. So 3/7. So I need to draw 6 lines. 1, 2, 3, 4, 5, 6. So this is Miss Brown's class. There are 42 students. And let's see here, 3/7 of them wear glasses. So 3/7, these 3 here wear glasses. So if we want to find what 3/7, we figure out what 1/7 is first. So 42 divided by 7 would be 6. So each of these are 6. And then we want 3/7, so we do 6 times 3, which would be 18. Is that right? Yeah, so 18 students wear glasses. Now you could have also done this using fraction multiplication. 3/7 of 42, or 3/7 times 42. And here you could simplify this before you multiply. 7 goes into 42 6 times. 3 times 6 is 18. You get the same answer. So, those were all the questions that were assigned. So make sure you're really familiar with simplifying fractions, adding, subtracting fractions, multiplying a fraction by a whole number, doing some conversions with different units, and that should be pretty good for the test. So good luck studying.
Y-E-A-H. Yay for math!